Today we're learning about evaluating functions, and you did this a little bit last year, but we're going to present it in a little bit different way. So last year when you looked at the equation like mx plus b, it was always equal to y. So we're used to this idea of y equals mx plus b. This year, instead of y equals mx plus b, we're going to say that f of x equals mx plus b. So we're just replacing y, so we're taking what was y, and we're replacing it with f of x. They mean the same thing. So y and f of x mean the exact same thing. So on our notes, we have a couple things to fill in. So we say that the y in the equation is replaced with f of x. And we read this as f of x. That's just how we say it. It's not f times x, it's f of x. And it's important to note that other letters can be used too. It doesn't just have to be F. Sometimes it could be G or H. So you could also have G of X, or you could have H of X. All they are is they just represent different functions. So if you have one that says F of X, then it's different than G of X, and it's different than H of X. They're just different. So if we need to write these following in function notation, well, y equals 5x plus 3 is going to become, in function notation, f of x equals 5x plus 3. And y equals 3x minus 100 would become f of x equals 3x minus 100. And y equals 2x squared plus 3x minus 4 is going to become f of x equals 2x squared plus 3x minus 4. So notice it's the same every time. All we did was we replaced that y with f of x in each of these. So y became f of x. So when we're evaluating functions, all we are doing is we're giving the function a value. We're giving the function a value. And a little bit more specifically, we're plugging in a number for x. We are plugging in a number for x. So on problem 4, it says, find f of x equals x plus 5 given f of 2. So it's important to note that in the parentheses here, we have x. So that means whatever they give us in the parentheses is also our x value. So to find f of 2, I'm replacing x with 2. So this 2 that we just plugged in was the same as this 2 that we were given in parentheses because they told us that's what x was. Well, now I just need to do a little bit of math. So f of 2 is going to equal, well, 2 plus 5 is 7. So that's my answer, is that f of 2 equals 7. And in an ordered pair, the ordered pair is 2, 7. And we knew the x was 2 because they already gave us that. And the y is whatever we got out as our answer, which in this case we got out positive 7. So that's where this y value came from. So problem 5 tells me that my x value is 2. So that means all of my x's need to become 2's. So I'm going to rewrite my problem. Instead of f of x, it's going to be f of 2 equals negative 4 parentheses 2 plus 7. It's very important to note that if you take out a letter and put in a number, you need to put that number in parentheses. And again, these 2's came from this 2 over here because it told us x equaled 2. So now we just get to do a little bit of math. So we get f of 2 equals negative 4 times 2 is negative 8 plus 7. And negative 8 plus 7 is negative 1. So that tells us that f of 2 equals negative 1. That also tells us that our x value is 2 and our y value is negative 1. Again, remember what's in the parentheses is our x value. That's where that 2 came from. And what f of 2 equals is our y value. Problem 6 gives us f of x equals x squared plus 2x plus 1. And they ask for f of negative 3. So again, they're telling us that our x value is negative 3. This time I have more than one x, but it doesn't change the way I do the problem. So I have f of negative 3 equals negative 3. Again, anytime you take out a letter and you put in a number, you're going to put that number in parentheses. So notice I put all of my negative 3's in parentheses here. So these negative 3's, remember, they came from this negative 3 that was in parentheses. So then we get to do some math on the right side. So f of negative 3 equals, negative 3 squared is 9. 2 times negative 3 is negative 6 plus 1. You can also just put all that in the calculator if you wanted to. So I get f of negative 3 equals 9 minus 6 is 3 plus 1 is 4. So that tells me two things. My x value is negative 3. My y value is 4. So I can put those in my parentheses. So negative 3 and 4. And again, that negative 3 comes from the x value. The 4 comes from the y value. Problem 7, similar problem. So they tell me that x is 1. So if we rewrite it, we get h of 1 equals negative 2. Instead of x, I'm going to put a 1 in parentheses minus 7. I'm replacing all of my x's in this case with a 1 because that's what they told me x was. So if I do the math, I get h of 1 equals negative 2 times 1 is negative 2 minus 7, and negative 2 minus 7 is negative 9. So our ordered pair would be the ordered pair 1, negative 9. The 1 came from what was in the parentheses, my x value. The negative 9 came from what it equaled in the end. Problem 8 is an identical problem, so this time my x value is negative 6. So I'm going to rewrite g of x, or instead of x, so I'm going to put negative 6 there, equals 2/3. Instead of x, I'm going to put negative 6 minus 5. Again, those negative 6's came from what they gave me in the parentheses, because that's my x value. So I get g of negative 6 equals, well, 2/3 times negative 6 is negative 4 minus 5. And negative 4 minus 5 is negative 9. So I know two things. I know my x value is negative 6, and I know my y value is negative 9. And that's, again, x is from the parentheses, negative 9 is what it equals. And lastly, we have f of x equals x plus 5, and they want f of 0. So that tells me x is 0. So I can rewrite this. Instead of x, I can plug in 0 equals 0 in parentheses plus 5. So f of 0 equals, well, 0 plus 5 is just 5. So I know that my x value is 0, my y value is 5, and that's because they told me x was 0. That was the original problem. And then when I worked it out, I got 5 as my answer. So it says, let f of t be the outside temperature, degrees Fahrenheit, t hours after 6 a.m. So remember, what's in the parentheses is our x value. So that tells us that t is our x value. And then f of t is going to be our y value. T represents our time, because it said t hours. And then our y's is going to represent our temperature. So our temperature is our y values. So the next part, explain the meaning of each statement, is in terms of what we knew up here about t and f of t. So remember, t is what's in parentheses. So when our time equals 0, that means our temperature is 58. And that means for number 9, where it says f of 6, that means when our time is 6, our temperature is going to be in degrees. We don't quite know how many degrees it is, but that's okay. Number 10 says f of 3, which means when our time is 3, and f of 9, which means our time is 9. Notice we have a less than sign there. So remember, f of 3 represents our temperature. So f of 9 also represents our temperature, and it says that f of 3 is less than f of 9. That means that the temperature is less. The temp at the time of 3 is going to be less than the temperature at the time of 9. So that means it's colder when t is 3 versus when t is 9. Part 2, we're going to use the graph to the right to answer A through C. So it says find f of 2. So remember, that means that x is 2. So we need to figure out when x is 2, what's y. So we're going to go over here to the graph. We're going to go to where x is 2 and find a point on the graph, and that would be right here. and y at that place would be negative, or positive 1, sorry. So f of 2 is positive 1. So when I have f of negative 1, that means I'm going to go to x at where x is negative 1 and go down. There's my point on the graph, and that point is at negative 1. And that would be this point here. And then find f of negative 4, so I'm going to go all the way over to negative 4 on the x-axis and go find a point on the graph, which would be here. And this point would be negative 4, negative 3. So that would be my last point. So for 12, we're going to use this function 3x plus 1 to answer. So for the first one, f of 1, I'm going to plug in 1 for x. So I have 3 instead of x. I'm going to put 1 in there, plus 1. 3 times 1 is 3, plus 1 is 4. For the next one, my x value is 0. So I'm going to do 3 times 0 plus 1. 3 times 0 is 0, plus 1 is 1. And then for part C, we have a table. Well, thankfully, we already have a couple of those values. We know that if x is 1, y is 4. We know that if x is 0, y is 1. So to find x when x is negative 2, I'm just going to plug in negative 2 for x. 3 times negative 2 is negative 6, plus 1 is negative 5. And then for negative 1, I'm going to do 3 times negative 1 plus 1. 3 times negative 1 is negative 3, plus 1 is negative 2. And then I also have to plug in 2. So I'm going to do 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So my table is now complete. And then we can graph those points on the graph over here to the right. So our first point was negative 2, negative 5. So I'm going to go down 2 and left 2 and down 5. Our second point was negative 1, negative 2. So I'm going to go left 1 and down 2. Our third point was 0, 1. So I'm going to go up 1. Our third point was 1, 4. So I'm going to go right 1, up 4. And our last point was 2, 7. So I'm going to go right 2 and up 7. And if I connect those, I get a line. So for problem 13, the function f of x equals 350 minus 125x represents the flight of a helicopter, where f of x is the number of miles the helicopter travels from its destination after x hours. Determine the domain and the range of situation. So remember, your domain is your x values and your range is your y values. So that tells us our domain is going to have something to do with our time, and our range is going to have something to do with our distance. So the point 0, 350 is going to represent, if we think about that, that's our x's, that's our time, and 350 is our distance. So when our time is 350, our distance is 0, so that means that we have 350 miles to go. That's how far we're going to be traveling, is 350 miles. And in order to figure out all the other questions, you need to make a table of values. So I have my x's and my y's. So at time of 0, I have 350 miles to go. At a time of 1, well, if I plug in 1 into this equation, so remember my equation is 350 minus 125 times x. Well, if I plug in 1 there, that's going to be 350 minus 125 times 1 is 125, and that's going to be 225. So after 1 hour, we'll have 225 miles left to go. And then I can do that again for 2 hours. So I have 350 minus 125 times 2. Well, that's going to be 350 minus 250, which is going to be 100. So after 2 hours, we'll have 100 miles to go. So I still haven't quite reached my destination yet, because I'll know when I reach my destination when I hit 0. So let's figure out about 3 hours. So if we do 350 minus 125 times 3, that's going to be 350 minus 375, which is going to be negative 25. So that means we've gone too far. So we're going to hit the ground somewhere between 2 and 3. So to figure out when we actually hit the ground, if we're trying to figure out when it reaches its destination, that means that our distance is going to equal 0. In this case, that's f of x is going to equal 0. So if we plug in 0 for that, equals 350 minus 125x. We can solve this for x. So we can move the 350 to the other side. Let's label our sides, x's, and everything else. So first thing I want to do, because I don't like the way it's set up, is I'm going to switch my sides. 350 minus 125x equals 0. So I'm going to move the 350 to the other side. It's going to be a minus 350. And then it's gone. So I get negative 125x equals negative 350. And then I'm going to divide both sides by negative 125. And I'm going to end up with x equals 2.8. So that tells us that after 2.8 hours, so I'm going to go back up here to the table and put 2.8 here in the middle, my distance is going to be 0. So I need to figure out a couple things. I still need to figure out my domain, and I need to figure out my range. And now I can do that. So my domain, well, that's my x's. And if you think about that, like, you're only going to be in the air, like, your time is only going to exist as long as you're actually in the air. So our domain's going to go from 0 to 2.8. So we're going to write 0 is less than or equal to x, which is less than or equal to 2.8. Our range, that's going to be our y, is our distance. Well, our lowest distance is 0. Our highest distance is 350. So my range is going to be 0 is less than or equal to y, which is less than or equal to 350. So now I can graph this by plotting all of these points. So I have, if I label my time as 0, 1, let's start back that over. Let's do 0, we're going to skip a space, 1, 2, and 3 hours. My distance, let's go by 50, so 50, 100, 150, 200, 250, and 300, and this would be 350 up here. So if I plot my points, my first point is 0 and 350. That was our starting point, so that's going to be here. My next point was 1 and 225. That's this point right here, 1 and 225. Well, 225 is going to be halfway between 200 and 250. My next point is going to be 2 and 100. So that's going to be here. And then we know we hit the ground at 2.8. So that's going to be my last point. So that's going to be somewhere about here on my graph. So if I connect it, this line represents the path of my flight. There's one other thing I want to talk about really quickly. If I ask, in terms of this problem, if I asked what does f of 2 represent? What does f of 2 represent? Remember, this number in here is your x value. So what f of 2 is going to represent is when time is equal to 2, what is your distance? That's what it represents. When time is equal to 2, what is your distance? Which in this case, we already know would be 300. So that would actually be, we could say that f of 2 equals 100, because we figured that out earlier, and that information comes from right here. I had 2 and 100 in my table. That's where that comes from.